All right, welcome back to Mr. P. Household Calculus, day 11 of Unit 2. So we are now exploring using product and quotient rule and all the other rules for tables and graphs. So you never really know what you're going to get when you're given a question, and you might be given a table or you might be given a graph. It's a lot of practicing what we'd already done. So now you're looking at the notes, you're probably wondering what exactly am I doing? So I'm using the quotient rule of this. So the first thing you want to do is always use the rules to find what h prime of x is. Then substitute, then solve. So you're always going to use those steps. And that's the work they're going to want to see on the final exam as well. So first, I'm going to use my derivative rules for quotient rules. So that's low d high minus high d low times the bottom squared. Then I'm going to plug in, because it says find h prime of 3. So then I'm going to plug 3 in for all the x's. And that's all I've done here. I didn't really show any work. Then I'm going to replace, well, g of 3, and I'm just going to use my table. G of 3 happens to be equal to 5. And then continue going through the process of substituting all the values in for whichever one they are. And then it's just a matter of simplifying. And that's all I did here to get negative 13/50ths is the final answer. All right, this is a product rule question. This is g of x times f of x. So the first thing I'm going to do is find f prime of x. Basically, I'm going to take the derivative of this side. So essentially, this is what I'm doing. Derivative of this side and derivative of this side. I'm taking the derivative of both sides of the equation. The derivative of k of x is k prime of x, because that's literally what that little prime means. And then to do the derivative of this, you would have to use the product rule. First times derivative of the second plus second times derivative of the first, or vice versa. It doesn't really matter the order. Then I plug in -1 for all the x's, which you see here, and then I look at the graph, and obviously you can't find k prime of -1 because that's the whole point. You're supposed to find what it is. G of -1. So I go to the g function. G of -1 is 0. It's right there. Now, in the case, there's no j of x on this question, so we're not using the graph just yet. So just first substitute all of these values in for the numbers and then simplify. On the last one, we have our constant multiple rule. Constant multiple rule was really just 2 times ddx of j of x. Well, the derivative of j of x is j prime of x, so it's just 2 times j prime of x, which if you look over here, j prime, if this is the key here. The function is j of x. So when you're looking for j prime of x, you're looking for the slope at that point. So j prime of -1, -1 is right here. J prime of -1 is not 7. That would be j of -1, not j prime of -1. So j prime of -1 is going down at a slope of, it looks to be -2 right 1, so -2. So it looks like j prime of -1 is -2 because that's the slope at that point. Now, of course, the slope could be anywhere along that entire line. F prime of -1, f prime of 1, well, that's up here. F prime of -1 is 1. It's right there. And then it's just a matter of simplifying, and boom, there you have your answer. One more. Here's another table. Now, this is a quotient rule question. Low d high times low d high minus high d low over the bottom squared. Then I plugged in 9 for all of the x's, and then I looked at the table to change them, or the j's obviously are down here on the graph. Same graph, same table, it looks like. And then I just simplified. For this one, this is a product rule question. This is, well, you could say, well, the way I did is I used constant multiple. I pulled that 4 out as a constant multiple, and then did f of x times this. So it's product rule, this times this. First times derivative of the second, plus second times derivative of the first. Now, if you're wondering, why did I just write g prime of x? Well, the derivative of -2 is 0. So there's no reason to put that. So the derivative of this entire term, well, both of them, the entire parenthesis is that g prime of x. And then second times derivative of the first, plug in 5 for all the numbers to find n prime of 5. Now that we know x is 5, and then substitute and solve to simplify. All right, j prime of 1. Where is 1? That is a corner. Remember, corners are not differentiable because the slope has to change gradually. The slope can't go from -2, so here m is -2, and over here it looks like m is +2. It's got to gradually change, like slowly change over time. I mean, it could change pretty quickly, but it can't change instantaneously. That's not how slopes work, how derivatives work. All right, j of 1. Well, j of 1 is just the height at 1. So that's 3. So the big difference between these two questions, one's just the height at 1, and the other one is the rate of change at 1. How the rate of change is changing. All right, and I think that's going to wrap it up for this video. Thanks again for watching, and I'll see you on the next.